In this video, we'll discuss reciprocal innervation, inverse stretch reflex, and negative feedback inhibition. So what's reciprocal innervation? In a stretch reflex, the antagonist muscles relax. How does it occur? The 1A fiber from the spindle from the protagonist muscle cause postsynaptic inhibition of the antagonist. This is known as reciprocal innervation. A collateral from 1A fibers innervates the antagonist muscles. And what's inverse stretch reflex, or how a muscle relaxes after contraction? After a forceful contraction, muscle relaxes suddenly. This is inverse stretch reflex. Receptor for the inverse stretch reflex is a Golgi tendon organ, and this is stimulated as a result of muscle contraction. When a Golgi tendon organ is stimulated as a result of muscle stimulation, muscle contraction, it sends impulse through the 1B fiber to the internuncial neuron in the spinal cord, and that excitation causes inhibition of the alpha motor neuron, and that causes muscle relaxation. The 1B fibers in the Golgi tendon organ causes inverse stretch reflex. 1B fibers are connected to the inhibitory interneurons. Stimulation of the 1B fibers produces inhibitory postsynaptic potentials. The Golgi tendon organs are stimulated by both muscle stretch and active muscle contraction. So what are the connections of the Golgi tendon organ? There are three connections. It's inhibitory to the homonymous muscles, it's inhibitory to the synergistic muscles, and is excitatory to the antagonistic muscles. Negative feedback inhibition. The excitatory alpha neuron may inhibit himself, sending a collateral to the inhibitory cells called the Renshaw cells. These Renshaw cells, they inhibit these alpha motor neurons. This is known as negative feedback mechanism. These Renshaw cells also inhibit the antagonist muscles. This is known as reciprocal inhibition. Neurotransmitter release is GABA, increases the permeability of the chloride.